Welcome. Today we will see the topic external sort merge algorithm. Basically, this external sort merge algorithm is efficient data sorting technique for large scale processing. So, if you are having a large data, then this external sort merge algorithm is very useful. We will see what is sorting. The sorting operation is required when SQL queries demand the output in a sorted order or for efficient query processing. For example, if I am writing a query like select star from table name, in where condition I want my output in a sorted manner, means we will be using this sorting techniques. Okay, so what is external sorting? What do you mean by external sorting? So this external sorting is a technique for sorting data that exceeds the available memory of a computer system. And when we are dealing with a massive data set that cannot fit entirely in a memory, we will be using this external sorting technique. So here the sorting can be performed by building an index on the relation. Then we can use this index to sort the data in the relation. So if a relation fit in main memory, then we can use any standard sorting algorithm like quicksort, insertion sort, merge sort, etc. And if a relation is bigger than main memory, then we can go for some sort of external sorting technique. So here the technique used for external sorting is external sort merge algorithm. So this algorithm works in two stages. So in the first stage, the relation will be divided as per the main memory space and individual part will be sorted and stored in the main memory. So here let us denote M. So M denote the number of blocks in the main memory buffer available for sorting. So in the first stage, as I said, that we are creating the number of sorted runs will be created, and each runs is stored, and in that each run some of the records will be in the sorted manner. Okay, so in the first step we will be dividing the data set into smaller part that fit in the memory. So read the this is the algorithm. Read m blocks of the relation. So we have divided our data sets into smaller m blocks, and then we are going to perform a in memory sorting. That is, each blocks is sorted individually by using some sort of sorting algorithms like quicksort, heap sort, merge sort, etc. And then we have to write this sorted data to the file, and we have to repeat this step until all the data and the relations get sorted. So each and every time when I am repeating, we have to increment the I value. In the second stage of this algorithm, we are going to perform a merge operation. This merge operation is represented as a n-way merge. This n represents the number of blocks or pauses being used to merge simultaneously. Here we can assume that n is less than m. If n is less than m, we have to use n block of memory to buffer the input runs and one block to buffer the output. So read the first block of each runs into the buffer page. Select the first record for all the buffer from all the buffer page. Write the record to the output buffer, and if the buffer is full, write it to the disk. Then delete the data from the input buffer, and if the buffer page becomes empty, then we can read the next block, and we have to repeat this step until our input buffer pages are empty. And if n is greater than m, we need to perform several merge passes are recurred. Okay, so in each pass the contiguous grouping of m minus 1 runs are merged. So a pass reduced the number of runs by a factor m minus 1 and it create the runs longer by the same factor. For example, if m is equal to 11 and if there are 90 runs, the 90 will not fit into our memory since our memory size is equal to only 11. So we have to split it, and in each passes it will be reducing the number of runs or blocks will be reduced from 9, 10, 9, 8. So likewise we have to reduce. We have to repeat this step until the merge is done into 1. Or now we will be seeing about the cost analysis, how to perform the cost analysis when we are performing this merge sort algorithm. Here consider a variable br, and this br denotes the number of blocks containing the records of a relation R. In the first stage it reads every block of relation and write them out again in the disk. So it will be giving a block transfer rate of 2 br. The initial number of runs is br by m. br by m. The total number of merge pass required is, we can calculate the total number of merge pass as log m minus 1 br by m. First, the final pass can be produced the sorted output without writing its result to the disk, since this is the first stage. In the second stage, there may be runs that are not read in or written out during the pass, and here we can at each runs to be merged in the pass, m minus 1 are read in and merged, and one run is not accessed during the pass. The total number of block transfer for external sorting for the relation, for the whole relation, is br into 2 log base m minus 1 into br by m plus 1. So this formula gives the total block transfer for the external sorting of a particular relation. So now we will see an example. Here the available buffer space is given as 64 blocks and my file is of size 4096. It consists of 4096 blocks, and so since it doesn't fit into the memory, we are going to use the external sort merge algorithm. And we are going to find how much merge passes are required in order to perform this sorting. Here we will consider m is equal to 64 blocks and br is equal to 4096 blocks. So our initial run will be br by m, which is equal to 64. At each merge pass it will be decreasing by, the number of runs will be decreasing by m minus 1. So therefore the total number of merge pass required is log m minus 1 br by m. So which is equal to log base 63 into 64, which will give me approximately 1.003. That means I need at least 2 merge passes in order to perform this sorting. And if you want to calculate the block transfer, initial block transfer will be performed by 2 into br, that is 2 into 4096. And if I want to calculate the overall block transfer, then we will be using the formula br into 2 log base m minus 1 br by m plus 1. So this will give me approximately 20,480 block transfer if I am considering the log value as 2. Thank you.